Hey, this is Geometry, Chapter 5-2, Perpendicular and Angle Bisectors. Okay. First term we're going to talk about is equidistant. We have a line, A and B. We have a guy in the middle, D, such that the two guys are equal from each other. Distances are the same. So we would say that from D to A and from D to B, they would be equidistant. And what equidistant means is that it's the same distance from these two spots. So this is the same and this is the same. Equal, distant, distance, equal distance from a given point. So from D to A and D to B, they're equidistant. They're the same distance from a given point. All right, and that leads us to our one of four theorems of the day. Perpendicular bisector theorem. And here's what the perpendicular bisector theorem says. If we have a line, or segment, a line segment, AB, if we have a line that goes through the segment, such that it cuts it in half, and it's perpendicular to the line segment. So we have here a line PM. Line PM cuts AB in half. That's what bisecting means, to cut in half. And it's perpendicular. It forms a 90-degree angle. Then we can say that any point on this line, this red line, if I was to draw a line out here and draw a line out here, these two lines would be the same. PA would equal PB. Any line. So if I was to draw some other line right here and draw it out to here and to here, not to scale, and to here, these guys would be equal as well. We can call this point X. Any point along this line, the perpendicular bisector, and if I was to draw a line out to these two guys, they are going to be congruent. They're going to be the same. So if line PM is perpendicular to segment AB and cuts it in half, so AM is equal to MB, then I can say that any point on this line going out to the segment are congruent as well, so that I can say PA is equal to PB. Note something. It says equal, not congruent. Most theorems that we've been dealing with has been congruency. This is equality. So please keep that in mind. Alright, so this is the perpendicular bisector theorem. Perpendicular bisector. Okay. We also have something called the perpendicular bisector converse. And what the perpendicular bisector converse says is that if we have line segment A and B, let's say I'm going to draw a perpendicular bisector right here. I'm just going to cut this guy in half. This is AB. It's going to cut this guy in half. And it's perpendicular we can call it M right here. Actually, I should have made this red. We'll call it M right there. We'll call it X right here. So it's line X, M. Okay. If I have some point out in outer space, just some random point, we'll call it point P, and I know that point P to A and I know that point P to B are the same, then the perpendicular converse says that this point P has to be on the perpendicular bisector, has to be on the line that's cutting in half. If I know that the point is equal on both sides, then I know that point P lies on the perpendicular bisector of A and B. So this perpendicular bisector converse. And again, it says if PA is equal to PB, then I can say that the line PM is the perpendicular bisector of segment AB. Remember, a perpendicular bisector cuts it in half and forms a 90-degree angle. Okay. So with that, you can do some algebraic stuff. Here, they want to find the length of QR. I'm not going to draw that triangle because it's not necessary. So they tell me it's a perpendicular bisector. I can look at it. It's a 90-degree angle, cuts it in half. So that means that these two guys are the same. So I can set them equal to each other. 5n minus 7 equals 3n minus 1. Subtract 3n for both sides. 2n minus 7. Add 7 to both sides. 2n equals 6. Divide by 2. N equals 3. Alright, since I want to find what QR in, I could plug it into either one, and I should get the same answer. So for QR, it's 5 times 3 minus 7. 5 times 3 is 15. 15 minus 7 is 8. So QR equals 8. But if I wanted to plug it into the other one, I should get the same answer. 3 times 3 is 9. 9 minus 1 is 8. So it checks. Good. So that's the perpendicular bisector theorem and the converse. Here, some silliness. This is ridiculous. But we have a theme park, and we have, I don't know, they want paddle boats. And they want spaceships. So we have a paddle boat and a spaceship. And we want to find where should I put the t-shirt stand such that it's equal to all sides. So if I was to draw a perpendicular bisector here and cut it in half, wherever that intersection is, since I know it's a bisector, I could call that my t-shirt stand. The t-shirt would be equal from the paddle boat, and the t-shirt's going to be equal from the spaceship chute, I guess. And that's where I would put it. You have to put a perpendicular bisector of that line. I think it's a silly question. Alright, distance from a point. This is not silly. We have a line. We have the point to that line. 2 points. The shortest distance from a point to a line, or the distance from a point to a line, will always be perpendicular, will always be 90 degrees. The shortest distance from a point to a line will always be 90 degrees. We don't even say shortest distance, we just call it distance from a point to a line. But it's always the shortest distance. Why? We can have other points to the line. We can have this point. We can have that point. We can have that point, right? And the same thing for A. We can have this point to that line. We can have that point to that line. Oh, that's not blue. That point to that line. We can have this point to that line. But here's the caveat. These guys are not the shortest distances. The shortest distance will always be a straight line, straight up and down, straight up and down. And so much so that we don't call it the shortest distance from a point to a line, we just call it the distance from a point to a line. All right, and knowing that information helps us with our next two theorems, is the angle bisector theorem. Before we get to angle bisector theorem, let's rehash, actually not go through it. Let's talk about what an angle bisector is. So we have an angle. And, no. We have an angle. Any angle. P, Q, and R. An angle bisector is a line or ray that goes through the angle such that it cuts the angle in half. So this angle is now being cut in half. Okay? I cut the angle in half, and we cut it at this particular spot. Let's call it S. What the angle bisector theorem says is that if I have an angle bisector, I know that this guy cuts it in half. Then I know that the shortest distance from any point to that line to the end of my sides of the angle will be the same. They're going to be the same. Not only that, I already know that the shortest distance will be perpendicular. Okay? If I use cut an angle in half, any point from that line to the end of the angle are going to be the same. This is the angle bisector theorem. And it says that if ray QS bisects angle PQR, then PS, okay, and SP is perpendicular to PQ, and SR is perpendicular to QR. Notice it says the ray QR and the ray PQ. Then I can say that SP is equal to SR. If I know that they're perpendicular, and I know it cuts the angle in half, then I know that those two segments are equal to each other. It's the shortest distance. Right? And I know it's the shortest distance because it's perpendicular. Okay? That's the angle bisector theorem. Then we have the angle bisector theorem converse. And the converse does the opposite. It says this. It says, it starts off like, oops. Do I have to redraw this? I guess I'll have to redraw it. It says, if I have a ray P, Q, and R, and I know that there's some point S And I know that point S is equidistant because it's the shortest distance. And I know that they're perpendicular. So that's the first condition. That's my if. If PQ is equal to PR and SR segment is perpendicular to QR ray and SP segment is perpendicular to QP ray, then I have enough information to say that segment QS, the line that it's on, ray QS, is bisecting the angle PQR. So this guy is the angle bisector, meaning that it's going to cut this guy and this guy in half. Okay, so it's the reverse. All right, what can I do with that? Well, if I know that something is an angle bisector, if we look at this one down here, I can set them equal to each other. Note this is the angle bisector, is cutting in half. These guys are perpendicular, so the angle bisector says these two guys must be the same. So I can say 6x plus 3, they want to know what FB is equal to 4x plus 9. Subtract 4x from two sides, 2x plus 3 equals 9. Subtract 9 from both sides, 2x equals 6, x equals 3. Alright, FB is 6x plus 3, so I plug in the 3. 6 times 3 plus 3, 18. 18 plus 3 is 21. That's FB. It should work for both, so I'll make that my check. 4 times 3 plus 9. 4 times 3 is 12. 12 plus 9 is 21. So I'm happy with that answer. Alright, so that's that section. Hope you have a great rest of your day.